Welcome to lecture 3 on module 1 of computer organization, in which we will be discussing about the various types of bus structures and the software that are involved, or the types of softwares that are involved in a computer system. In case of any computer systems, we know that the speed is a primary criteria. As far as a computer system is concerned, we accept, or we prefer a higher speed of data transfer or the computation. In order to perform that, the data has to be transferred from one block to the other block as fast as possible. And this transfer of data is performed by connecting the various devices using a group of lines. And these group of lines that connect different functional units is called a bus. When this data is transferred, and it will be transferred in parallel, and each wire will have or will carry a one bit of information at a time. These bus lines not only carry the data, it also carries the address as well as the control signals that are generated from the control unit. The diagram here shows one of the types of bus which connects the different blocks such as input, output, memory and the processor. Basically, in case of any computer systems, you will have two types of bus arrangements. One is the single bus arrangement and the other one is the multiple bus arrangement. In case of single bus arrangement, as the name suggests, it will have only one bus, and it will be limited to transfer only one data at a time, because of which the transfer is limited between the two functional units. So what happens in that case is, even though all the units are connected to this bus, only two blocks can actively involve in the transfer of data. The main advantage of the single bus is the low cost and flexible to attach to the peripheral devices. It is very flexible. Whereas in case of higher level performance can be achieved using the multiple bus arrangement. In case of multiple bus arrangements, you will have multiple or many number of bus arrangements, because of which you can transfer many data at a time. The performance of the device automatically improves. As the number of bus increases, the cost of the setup also increases, thereby increasing the cost of the entire system. Previously, I said that all the functional units are connected to the single bus. What happens in that case is, all the functional units may not be operating at the same speed. For example, if you have a computer system, it has a keyboard, it has a processor unit, it has a memory. The data transfer taking place between the processor and the memory, as well as from the keyboard to the processor, may not be same. In such cases, what happens is, the device gets locked up when there is a multiple request is arrived. The input unit, like keyboard and the printer, are the devices that convert one form of input to the other form. In case of keyboard, the keyboard converts the input given by a user into some digital form, and the printer converts the digital input it gets into a printed form. So these are the electromechanical devices. These are considerably slow. They cannot operate as fast as the processors can. And these secondary storage devices, such as the magnetic disk, optical disk or USBs, these are considerably fast as compared to the electromechanical devices, because it need not convert one form of data into the other form. It just need to transfer data from one location to the other location and store it there. So they are relatively faster as compared to the electromechanical devices. Along with this, we have the memory and the processor, which are the devices that present in the computer along with the input unit, output unit as well as the storage unit, which are operating at the electronic speeds, making them one of the fastest parts of the computer. The processors are the very faster in case of the computer system. Now let us consider all these devices such as keyboard, printers, magnetic or optical disk, and the memory and the processor, which are operating at a variable speed and connected in a single bus arrangement. So what happens is, as we discussed earlier, the device gets locked up when a slow device transfers the data to a processor. The device gets locked up. In order to smooth out these differences, the common approach is to include the buffer registers with the devices to hold the information during the transfers. So what happens if one of the unit tries to transfer a data? If there is no buffer register, the data is lost because the bus is not available to transfer a data at that particular moment. The data or the function, any other functional unit that tries to transfer the data at that particular moment is lost. In order to avoid that, it is necessary for us to add the buffer registers that will hold the data, and once the bus is available, it starts transferring that particular data. See, these buffer registers will smooth out the timing differences among the processors, memory and the IO devices. Whatever, even though the units or the devices may operate at variable speed, but these buffer registers will take care of smooth transfer of data without missing out any of the information. For example, in this case, let us assume a processor wants to read a single character from any keyboard and it want to print the same character using the printer. Now what happens is, the processor has to scan for the key that is being pressed, process it and print it using the printer. Now when the printer is getting ready to print the red character, the processor as well as the bus is free. So what happens is, as soon as the character that is ready to be printed, it will be loaded into the buffer registers and the printer will release, or the processor will give command to release the bus from the printer so that the control can be given or the bus can be handed over to the other functional units to perform a normal operations. The software in case of the computer systems can be classified into different types, such as the system software, application software, text editors, operating systems and so on. The system software is responsible for the coordination of all the activities that are carried out by a computer system. The system software is responsible for the proper functioning of a computer system. So this system software is a collection of programs that are executed as needed to perform the functions. The functions, like, see here in the first point, here receiving and interpreting the user commands. So if you might be using some of the shortcuts like Control C, or you might be using delete buttons, or you may be using some other user keys that are present in the keyboard of a computer system. When you press any key, what function it has to perform, it will be interpreted using the commands, and these commands are nothing but the part of the system software. If this program is not present in any system, then it is not possible for you to use the keyboard in a proper way or in a normal way what you use. For example, if you have if there is no command for using Control C, that is copy, it is not at all possible for you to copy the program. So such kind of commands for receiving and interpreting the user commands, the system software is required. And the next is the next one is, just a second, here, entering and editing application programs. So you are using various softwares to write, or for example, for in case of C program, let us assume in case of C program, you will be using certain software to write and execute the program, and also that program is stored in the secondary memory of the computer system itself. So these entering and editing application programs, that cannot be done as such. You need a background program that is running in order to manage all those. That is nothing but the system software. Now let us imagine you have a music that is stored in a secondary storage. Let us assume that it is in the USB, and you want to play it. You want to hear a music that is stored in a USB. Then in such cases, there should be a program that manages the storage and retrieves the file from the secondary device. Your USB acts as a secondary device, and that data that is stored in the secondary storage has to be retrieved, and it has to be played using a proper player. Again, in order to perform those operations, there is a program required that is nothing but a system software. Running a standard application programs such as Word, spreadsheets, or games that has a user interface to edit or do such operations. Even for that, there should be a background code running, that is the system software. And there are many operations that are performed in the computer system. All those functionalities require some background program running. That background program is nothing but a system software. Along with the previously mentioned points, we need the system software to control IO units, to receive the input information, and also to produce the output results. To perform this task, we need some background program. Along with that, we have the translating programs from the source form prepared by a user into an object form consisting of machine instruction. This is required for a compiler, or we have development environments to perform some of the coding, in which it is necessary for us to convert one form of code into the other form, so that we can execute those codes remotely. So in order to perform these tasks, there should be a system program that is running in the background. And in the same programs, we may get different types of files. To run it in a single platform, we need to link those, or for an application to run properly, we need to link those. Even this task is performed by the system software. So the system software, as I said earlier, it is responsible for the coordination of all the activities that are carried out in a computing system. The other form of software that is involved in computer systems is the application software. The application softwares can be written in two ways, that is either using a machine language program or higher level language program. The higher level language program is preferred by most of the programmers. The reason is the easiness of writing a program. The programmer need not know about the target processor on which the program is going to run. He need not worry about that. He just goes on writing the program in higher level language program. However, we know that any processor will understand only the machine language program. It will understand the program can be written in any higher level language. Ultimately, it has to be converted into a machine language program, from which it will be converted into a binary file. So this operation of converting a higher level language to a machine language higher level language to a suitable machine language program is done by the compiler. Another form of system program is the text editor. These text editors are used for entering and editing the application programs. So if we imagine, if we take an example of writing a C program using a code blocks or Visual Studio or whatever the editor is, these are nothing but the text editors. These are used to write the programs or give the different commands or execute the commands that allow the statements of source program entered at the keyboard to be accumulated in a file. So what happens in case of that code blocks, you will be going on writing a command using the keyboard and it will be accumulated into a single file. And this single file is a sequence of alphanumeric characters or a binary data that will be ultimately stored in a memory or in a secondary storage. And these files can be given the name chosen by the user. This type of softwares are called as the text editors. The operating system is a collection of routines that is used to control the sharing of resources between the various computer units as they execute the application programs. Whenever the application programs gets executed, it requires various resources, such as it requires memory, it requires some of the data files, it requires some of the data from the secondary storage, it requires the movement of data between the memory and disk units, it requires some data to be received from the input units, or it has to send some data from the processor to the output unit. All these handling of these resources are done by the operating system. In order to understand the basics of operating system, let us consider a system with one processor, one disk and one printer. Assume that the application program is written in a higher level language and it has been converted to the machine language program and is stored in a disk. The very first step in this case is to transfer the file into a memory, that is the compiled file. The compiled file that is in the form of a binary has to be transferred to a memory. When the transfer is complete, the execution of the program starts. The program's task involves, the application involves reading a data file from a disk into the memory and performing some computation on data and printing the result. That is, it has to read the file from a disk, process it in a processor and print it. This is the task that we need to perform. In this particular slide, we can clearly understand the functionality of the operating system. In our previous slide, we had discussed while discussing about the operating system that the functionality of the operating system is to provide the resources and control the resources. So here in this example, the data file that is present in the disk is the resource, and this resource has to be allocated to the application program by the operating system. So once the data file that is present in the disk is stored in a memory by the operating system, the application program performs some computation on the data file that is in the memory. Once the computation is completed, the result is ready to be printed. At that particular moment, the application program sends the request to the operating system saying that the data that has to be printed in the printer is ready. As soon as the signal is received by the operating system, the operating system sends the control signal to printer to print the result. In both the cases, the operating system is responsible to allocate the resource, that is the data file, in the first case, the data file that is present in the memory, present in the disk, has to be copied to the memory. That is done by the operating system. And in the end stage, where the result, the file is ready in the memory, the result file is ready in the memory, that has to be transferred to the printer. That is done by the operating system. The main job of the operating system is to handle the resources in an optimized way so that the performance of the device is increased. In this particular slide, we can clearly understand the OS routine and the program flow in more clearer way. Initially, we know that the program, the application program, is stored in the memory or the disk. It has to be transferred to the memory, and that will be done during the time period T0 to T1. During this period, what happens is the program is loaded into memory. So what happens once the program is loaded into the memory? Once the disk allocates the program into memory, the OS routine passes the control to the program. The program starts running. Once the program starts running, the data file has to be, the program requests for the data file that is present in the disk. The program requests for a data file that is present in the disk. So it passes the control back to the OS routine to allocate the resource. The resource is in the disk. This resource has to be allocated to the application program. Once the allocation is completed, once the disk allocates the data file to the memory, it passes the control back to the OS routine, and OS routine in turn sends the command to the application program that the data is ready for computation. At this stage, during the time T3 to T4, the computation of the data file takes place. Once the computation is complete, it sends the control signal back to the OS routine, saying that the data file that is present in the memory is ready to be printed. In turn, the OS sends the command to printer to print the specific data. Once the printing is complete, it will transfer the control back to the OS routine. So in this case, since there is only one application, that is one application to be executed, it feels very simple. If you clearly visualize this particular process flow, at one stage you feel that the processor as well as the programs are idle. At this stage, when there is in between T4 to T5, the processor, during this period, the processor is idle. So what happens is, in such cases, the OS can be allocated to perform some other task. So that a multiple task can be handled at a time, thus increasing the efficiency. This type of programming or this type of concurrent execution is called as the multiprogramming or the multitasking. Here, once the program that has to be printed using the printer is loaded into the printer, it has nothing to do with the disk. It has nothing to do with the disk, OS routine, nor the program. So what happens is, during this period, another application can start running. Application can be loaded from memory. By doing this, a multitasking approach can be performed, or the multitasking application can be performed, thereby increasing the efficiency of computer system.